Today we are going to discuss the assignment number 3 from dealing dealing with material data collection analysis and interpretation course. Um, so let's go directly to the question number 1. So plot the stem and leaf plot for the elastic modulus data with the scale. With the scale is equal to 2. Which of the following is a correct stem and leaf plot? They have asked. Okay, first let's see how to plot a stem and leaf plot. For that they have given the data like in the form of .csv file, comma separated values. So let's read that file, whatever data is there in the file, directly to the variable x. So x is invoked with values from read dot values from the modulus underscore hardness file. Then let's call this library ggplot2, because actually here sorry, it's wrong. Like I thought of plotting using ggplot, but later I thought we can normally plot with this thing. Yeah. So just stem plot with x. First column is nothing but the elastic modulus value, and second column was hardness. So we are just trying to plot the modulus value. So let's take the first column. So that is elastic modulus with the scale of 2. So now we have plotted. So this is the answer which in the answer key they have given. Yes, we can also plot using ggplot. So I tried, but I didn't enclose it here. Yeah. Okay. Second question is, using R, generate a summary report of hardness data from question number 1. Which of the following options corresponds to the report you have generated? Okay. First of all, summary command gives the overall values, like from minimum, first quantile, then median, then third quantile, and what is the maximum mean, and what is the maximum value possible. All this data, maximum data value for that particular point, all this data will be given. All this data is given by the summary command. So here we use first, as usual, we read the .csv file and we accumulate the data. I'm generating a summary for first column, that is modulus column, using this command. Then for this is for the um, hardness. So for both we have generated the summary report. So they are asking, okay, question. Based on that question we can compare this data and answer. They have asked for the summary. You For the elastic modulus we have to take this. For summary for um, hardness we can take this. So third question, which of the following command will not give you a property based report of a given data in R? So property based report means mean, median, mode, all these things will come under property based reports. Standard deviation, this variance one, they will come under rank based method. This is property based. So rank based. So the question is, so the following command will not give you a property based report. We can take both standard deviation and variance. Okay, so let's go to the next question. So in case if you guys have doubt in this, we can discuss late. Means we can discuss, like you can send a mail, or I can give my mail ID in the uh, end of this session. I will just tell my mail ID, so you can write to that mail ID. I'm ready to help you in it anytime, even during the non live session days. Okay. So fourth question: suppose you want to plot a box plot as shown in the figure. Okay. For the hardness data, which of the code snippets are given the correct answer? Okay. um, Actually, in the question it is given like a notch type box plot. This notch tells the 95% of the um, confidence values will lie under this range, like that. That is what that notch gives. Notch information gives. So if you we will just go plot for each and every option they are given, what we are getting. So if you just give box notch false means okay, these things we already know. We are reading the CSV file, then we are assigning that first column, sorry, the hardness to the hardness variable, hardness values of the nano data to the hardness variable. Then we are what is it? Yeah. Then we are plotting it using in box and whiskers plot, and in this we can give we have given horizontal. All the options have horizontal, which means it will appear in horizontal fashion. And this is X labeling, Y labeling, then sorry, X labeling, then giving title to the plot. Then here comes the actual here comes the difference. Here we have given the notch is equal to false, means we won't get that notch. So here a simple explanation is, if you give instead of false, if you give true, you will get that notch. That is what they are asking for. So anyway, let's go to the next one, next command. Here everything is same. Here they have neglected that notch false, which means like by default the notch is not invoked into that command. So if you want notch, you have to specifically give notch is equal to true. So that is what here they have given and got the notch. So the one more thing is like improving the aesthetics of the plot. For example, color of that plot is orange, then border is brown. So this is what they have given. They have improved the aesthetics. Apart from that, everything remains same. Okay, let's go to the fifth question. Which of the following scripts will plot the scatter plot of hardness data and also draw a line along the mean value of hardness as shown below? Okay, so first, simply what we have to do is like, first we have to plot this scatter plot. Then we have to we have to include this mean line, so that we will know how the values are scatter, means how the values are um, whether they are close to the mean or how they are away from the mean. This will give the extremities. These are telling that they are in the extreme end of the plot. Okay. Okay, for that, first just simply first either we can find mean, and we can give AB line h is equal to 6, or else we can means AB h is equal to whatever mean value you have got, that we can give, or else we can um, directly invoke that mean function into this. So it can be done by first you read the data values, whatever uh, is there in the file. Then that is given the defined hardness data set. Then plot x. So it will plot by default it will plot the scatter plot. Then after that you can give h mean is equal to x, and you can give AB line h is equal to h. This can work out. This can produce this kind of median line in the graph. Otherwise you can directly invoke this function into this h is equal to mean. So both can give the same result. So as professor has mentioned, this can be a software as well as a programming language. So we can directly invoke that function into a variable rather than attaining a value to that variable and calling it again. Okay. So let's go to sixth question. Sixth question. Here they have used a different library function from a different library. For this, many of us would have not installed this library. So first, it is better to search whether this whether this library is installed or not. That can be checked using search command. First, you search for the search and see like what all the libraries have installed. If this library is installed, then you are good to go. Otherwise, type install.packages FITDASTR plus and enter. Then it will be installed. After that, you invoke that function to this. You load that library. You can if not, like if it is already installed, you can directly load the library and you can directly call that to a variable. So this will give you summary statistics. In this, you'll have elaborated way. In the before summary, it is like only the property functions, whatever it is there. Only property, yeah. Basically, property functions are given. Here, you will get all the data. So, example, standard deviation, skewness, kurtosis, everything you will get. So, based on this, we can answer this question. 0.087 and 2.38. So, yeah. Let's go to the seventh question. Seventh question is which of the following options gives the correct values of interquartile range for hardness and modulus respectively. So using R to calculate two quantities from data set mentioned in the question. Okay. So you have to take the question one as the input data set. So using that, what simply just we can, there are two ways, like it's like manual ways, like we can directly give summary and we can get the first quantile and third quantile and we can find the difference to get the interquartile range. Otherwise, you can give this command IQ or interquartile range for the first column, that is nothing but the elastic modulus. So you will get the interquartile range, and for the second column which is nothing but the hardness, we can get the interquartile range by IQ or X of the second column values. So let's go to the eighth question. Eighth question, they have given the data set of density uh, and conductivity of a material, um, sorry, water and brine solutions. So for whatever higher than 1, they have depicted as high density range high. For less than 1, they have given us low. So what they are asking is like uh, okay. I think the question, I didn't copy the question here. I think the question is to filter out this lower range and assign to a variable, and then um, plot a graph for density against conductivity, density versus conductivity for that lower range of density values. For that, first you will I have taken a variable y and I have copied all the means I have invoked the file data set from the density.csv file. Then we can separate out the lower range values by calling this is one, right, 1 2 3. So we can uh, compare this low string values with the first column, and whatever matches will be copied to I1. So plot y of I1 uh, comma 2 means it will take this I1 means the low, and I1 in the sense whatever the result of this I1 is uh, all these column values. So now it will take this, and all these values will be plotted against conductivity. I1 comma 2 means all these values will come, then I1 comma 3 means all these values will come. So we are plotting density versus conductivity for low. So likewise we will get this plot. Okay, let's go to the ninth question. It's kind of continuity. So consider the density versus conductivity data set from the question 8. Yes, suppose we want to generate two plots of conductivity against density such that the plot of the left only shows the density values less than 1. The plot on the right shows the density values greater than 1. So earlier what we have done is we have plotted this. So density value is less than 1, and the second part of this is like we have to plot the density values greater than 1 also. So the following scripts can make this plot. Okay, for this we use this PRM row, column 1 comma 2. So row is 1 and column is 2. Likewise we have to plot. So as like before previous question, we have um, read the values. Sorry, we have compared this low values and wrote those values to I1 and I2 to the high. So high and low are separated now. High density values and low density values are separated. Then it is plotted. So a plot y of I1 comma 2 and I of I1 comma 3. Then we are just giving the labels to x and y axis as density and conductivity. Likewise we will get the plot. Here it's I2 means whatever it is there in high will be compared I2 comma 2 to I2 comma 3. So finally 10th question, what they are asking, like what are the x and y axis of the Cullen-Frey graph. So Cullen-Frey graph has all the information of distribution, then kurtosis and square of skewness. So from I have generated this graph from the summary report of that hardness and elastic modulus data set. So here as we can see, it is plotted between the square of skewness and kurtosis. Okay, I think we have discussed all the questions. Like if you have any further doubt, you can mail your questions to type it to this mail ID. I can answer all your queries. If you have any further doubt, we can also have a separate session for each people or like group of people who are having doubts. So thank you.